Hello, everybody. My name is Jiangning Liu. I'm from ARM company based in Shanghai. And ARM and Qualcom are implementing aarch64 neon instruction set on LLVM trunk. So Anna, who is from Qualcomm Innovation Center, and I would like to give a short introduction of the current status. Now we have a couple of implementation goals. First, we want to implement all of the aarch64 neon instructions falling into 25 instruction classes, including both SISD and SIMD instructions. And we also want to implement all of the ACLE intrinsic functions. ACLE stands for ARM C language extensions. And we also want to provide fully 32-bit backward compatibility, which means we want to keep all of the 32-bit intrinsic functions and also make them work for 64-bit as well. Finally, we also use the integrated inline assembler by default. So that means we will cover every details of the MC layer implementation. And this is the current status. The number, the digit here shows the total number of the instructions for each instruction classes in the leftmost column. And the column with the green subject means the 100% complete on chunk. And the yellow one means under code review. And the amber one means the active development. So the last row shows the current status, but the 100% completed on a chunk is a little bit out of date because we did several commitments early this week. So now it's almost 70% on chunk. Some implementation details. First, we want to avoid introducing more LLVM IR intrinsics. So that means we want to reuse the IR intrinsic functions being defined by ARM backend as well. So that means that could provide some IR level flexibility, improve the code, better code generations. We also have a couple of SSD instructions which implemented almost the same functionality as the instructions using GPR, but implementation is a little bit different. At this moment, we use the V1X and the V1FX as the scalar data type to distinguish them with the instructions using GPR, but this could be changed in future when we have a global instruction selection. That means we can have the better decision to do the bank selection. And we also share the ARM-neon.h between the ARM backend and the aarch64 that can fully guarantee the 32-bit backward compatibility. We also want to tune the for the current selection DAG-based scheduler, we have to overload the cost model to support some big data types like V4, aarch64, which is introduced by the vector list from the load store instructions. So, and considering some extra benefits from MI-based scheduler, we want to enable the MI-based scheduler by default. And we also use the register operand to inherit from register class to avoid some redundant register transformation. And in addition to the LLVM regression test, we also have a couple of other tests. We have the auto-generated ACLE unit test to check the correctness of the binary generated mapping to the individual intrinsic functions. We also use the MC hammer to compare with GCC. We also have a special emperor test, which is to check the semantic correctness by using randomly generated ACLE composition C test. And we also want to introduce more workloads to verify the correctness of the pattern matching. And our goal is to complete this task by end of November, but we hope to complete it before the 3.4 branch creating. And the remaining work will be all about performance tuning. For the first one is to compare with GCC using the foundation model being provided by ARM at this link. And the second, we also want to tune MI-based scheduler. And the last, we also want to tune the SLP, which is, after all, the real customer of our pattern match. At last, the acknowledgments, want to thank Chad, who is from QuIC, and Hao and Kevin, who is from us based in Shanghai. Particularly, we want to thank Tim, who did a lot of code review work, gave us a lot of guidance. And last, we also want to thank other code reviewers in the community. Thank you.